As we've seen before, for the question answering tasks, the inputs will be the question and the passage, and the output will be the answer to the question, which is a segment of the passage. Here, reduced blood glucose levels can be found in the passage right here. We can represent the answer using the start and end words of the answer. So reduced blood glucose level has the start word reduce and the end word level, and reduce is the 11th word if we start counting in the passage, and levels is the 14th word in the passage if we count from the start. So going back to the word representations BERT learns, the task for the model is to be able to determine whether each word in the passage is one of the start or the end of an answer to a question. Here's how the model learns to determine whether a word is likely to be the start or the end word to an answer. The model learns two vectors, S and E, for each of the word representations for each of the words in the passage. The word representation is multiplied by S to get a single number, which is the start score for that word. The higher the start score, the more likely it is to be the start of the answer. So for example, the word reduce is more likely to be the start of the answer than the word blood. Similarly, for each of the word representations, the word representation is multiplied by the vector E to get another scalar number, which is the end score. The higher the end score, the more likely the word is to be the end of an answer. So for example, the word levels is more likely to be the end of an answer than the word by. Using these start and end scores for each of the words, we can find out what the most likely answer is. We do this by computing a grid of words. In this grid, we enter in the start score plus the end score in each of the cells, the start score coming from the rows, and the end score coming from the column. For instance, to compute the score that the answer starts with blood and ends with glucose, we would fill in this cell, and we would get the start score from blood, that's 0.1, and add it to the end score from glucose, which is here, again, 0.1. to get us a score in the cell of 0.2. We can thus compute the scores for all entries in the grid. We can force the end word to appear no earlier than the start word by only computing the scores in this upper triangular region. Remember that if we went here, then we're saying that the start would be after the end, which is not possible. The model thus outputs the start and end word corresponding with the highest score here. The highest score here is 8.2, which has a start with reduce and an end with levels. And so we have the model output reduce as the start of the answer at token 11 and levels as the end of the answer at token 14. The model learns the vectors S and E and updates its word representations based on being shown many of these question, passage, and answer triplets. Typically, the model is first shown natural question and answers in English in the general domain using datasets like SQuAD, and then fine-tuned on medical datasets like BioAsk.